Welcome to More Learn, More Teach, where I attempt to simplify the complex. We will start our series on unit conversions and systems of equations. We'll be exploring what it really means to be equal. So, what does equal mean? If this is equal to this, then it must be true that I can replace every one of these with one of these and vice versa. How does that affect us? Well, I could take a ratio. Let's say I had a ratio of 2 blues, right? So anything that is divided by itself will be 1. So that's equal to 1. Same thing here, 2 blacks. So something divided by itself is equal to 1. And because of this relationship, because this is equal to this, because the black is equal to the blue, that means that if I divide black by blue, or if I were to swap these and divide blue by black, I would still have 1. This is vital for us to understand how to do unit conversions and systems of equations. Example, let's say that I have one toy cost 2 gems. That means if I wanted 2 toys, I would have to pay 4 gems. That also means that if I traded in 3 toys, I should be able to get 6 gems. So now let's use a system of equations to solve a relatively simple problem. We're going to look for the number of millimeters in a mile. And to do that, we're going to use a system of 4 equations. Those equations are 1 foot is equal to 12 inches, 25.4 millimeters is equal to 1 inch, 1 yard is equal to 3 feet, 1 mile is equal to 1,760 yards. So given that information, let's find the number of millimeters in 1 mile. So let's start with, I have 1 mile. I divide it by 1 to make it more straightforward, more simple what I'm trying to do. So that I'm going to divide out the miles. So I know that I have miles, I need to get rid of the miles. So I need to use one of these equations that has miles in it. So I'm going to use this equation that 1 mile is equal to 1,760 yards. This is true, therefore I can take a ratio of 1 mile divided by 1,760 yards, that's equal to 1. I could also say that 760 yards divided by 1 mile is equal to 1. What's helpful here though is I need to have the miles in the denominator. That way I can cancel out these miles here. So the equation that helps us the best here is that I have 1,760 yards divided by 1 mile is equal to 1. So I can multiply anything by 1. The thing I started with was 1 mile. So therefore I can multiply it by any type of 1 that I choose. The type of 1 that I'm choosing here is 1,760 yards divided by 1 mile. So now the miles cancel out. And if I multiply this quantity by this quantity, I would have the number of yards in a mile. Okay, but that's not what we're trying to solve. We're trying to solve millimeters. So now we got to get rid of these yards. So let's use this equation to get rid of the yards. So 1 yard is 3 feet. It's exactly the same as 3 feet is equal to 1 yard, or 3 feet divided by 1 yard is equal to 1. 1 yard divided by 3 feet also equal to 1. What helps us out in this case is to put the yards in the denominator. So I need to get rid of these yards. So 3 feet divided by 1 yard is this equation. This is the 1 that I'm multiplying by this quantity. So 3 feet divided by 1 yard, that is equal to 1. Therefore, I can multiply it by this quantity. This will cancel out my yards. And if I were to take 3 and multiply it by 1,760, that would tell me the number of feet in a mile. Again, not what we're trying to solve, so we'll continue on. So now I have feet. I want to get rid of the feet. So I have an equation here that has feet in it. We've already used this one. That one's not going to help us. We're going to use this one. So 1 foot is 12 inches. 12 inches is 1 foot. Therefore, 1 foot divided by 12 inches is equal to 1. And 12 inches divided by 1 foot is equal to 1. Again, I want to get rid of the feet, so I need feet in the denominator. So the 12 inches divided by 1 feet, that's the 1 that I'm multiplying this quantity by in order to convert to inches. Okay, so now the feet will cancel out. And if I wanted to know how many inches were in a mile, I could multiply 1 by 1,760 by 3 by 12, and that would give me the number of inches in a mile. So now to finish this out, I need to get rid of the inches and get to millimeters, which is what we're trying to solve. So I have this equation, which is 1 inch is equal to 25.4 millimeters. Also, 25.4 millimeters is equal to 1 inch, or 1 inch divided by 25.4 millimeters is equal to 25.4 millimeters divided by 1 inch is equal to 1. Therefore, I can multiply all this stuff by 1 without changing the quantity. 25.4 millimeters divided by 1 inch. Now the inches will cancel. And I have the number of millimeters in a mile is equal to 1 times 1760 times 3 times 12 times 25.4. All this equals 1,609,344 millimeters. This is also equal to 1.609344 times 10 to the 6 millimeters. Depends on how you want to express it. Here's a little more complicated example. Let's say that we have 1 Pascal is equal to 10 dynes per centimeter squared. That's a unit of pressure. We have 1 erg is equal to 1 dyne centimeter. That's a unit of energy or work. 1 acre is 4.05 times 10 to the 7 centimeters squared. It's a unit of area. We have 1 stone is equal to 6.23 times 10 to the 6 dynes. And that's a unit of force or weight. We have an equation that pressure is equal to force divided by an area. And we have that work is equal to force times the displacement. So given these 6 equations, this system of 6 equations, let's solve 2 problems, 2 questions. How many stones does a man weigh that did 1 erg of work while stepping down 1 centimeter? That's one question. Next question, how much pressure did he exert on the ground below a 1 acre massless plate? We'll use the work equation. So work is equal to force times displacement. Therefore, the force is equal to the work divided by the displacement. From our problem, we know that 1 erg of energy was used to displace 1 centimeter. And now we need to convert that into stones. So we'll use the same process we did in the last example, except now we have 1 erg divided by 1 centimeter. To get rid of the ergs, I will use the equation that 1 erg is equal to 1 dyne centimeter. So that will get rid of my ergs, leaving behind dyne centimeter per centimeter. That gets rid of the centimeters. So all I have is dynes left. Now I have my equation that 1 stone is 6.23 times 10 to the 6 dynes, which now cancels out my dynes. Multiplying all these ones, dividing by 6.23 times 10 to the 6 gives us 1.61 times 10 to the minus 7 stones. It's a pretty small man. Pretty small man. All right, so second part, we now need to find the pressure. So we're looking for how much pressure does this man exert on the ground below a 1 acre massless plate. So pressure is equal to force divided by area. And we now know how much force is applied. So this much force is applied to the plate. It's a 1 acre plate. And we're trying to convert this into pascals. All right, so if I put what I have, which is 1.61 times 10 to the minus 7 stones divided by 1 acre, and then I start building my track to remove what I don't want in order to get what I do want, which is pascals. So our target, we got to keep our target in mind. It's really easy to get lost in the minutia going through one of these equations. So you get to start with this, and then you're trying to build towards something. What are you building towards? You're building towards pascals in this case. Okay, so in order to get rid of my stones, I'm going to use 6.23 times 10 to the 6 dynes per stone. That will get rid of my stones. I will use that 1 acre is equal to 4.05 times 10 to the 7 centimeters squared. That will get rid of my acres. And now I'm going to do something crazy here. So I need this to be a quantity of 1. It doesn't come out all pretty, so I use some math magic here. So 1 Pascal is equal to 10 dynes per centimeter squared. True statement, because we have that relationship from our givens. Therefore, 1 is equal to 1 Pascal over 10 dynes per centimeter squared. Okay, that's just dividing both sides by 10 dynes per centimeter squared. It gets us this. This is also equal to 1 Pascal centimeter squared, because when I divide by a fraction, I invert and multiply. So I invert and multiply, which gives me 1 Pascal centimeter squared divided by 10 dynes. That's how I get to this part of the equation. Okay, so it's hard to see that just by looking at this. You got to understand this relationship. This is the equation I used. I used algebra to manipulate it to suit my needs so that I could fit in this equation easily and cross out what I'm trying to cross out, because I know the target in mind. I'm trying to get pascals. If I didn't know where the target was, I could just do whatever, right? But I'm trying to get to pascals. So I now have this. I can cross out my centimeter squared. I can cross out my dynes. And now I multiply 1.61 times 10 to the minus 7 times 6.23 times 10 to the 6 divided by 4.05 times 10 to the 7 divided by 10. All that equals to 2.47 times 10 to the minus 9 pascals. And that's our answer. All right, let's finish this video with an abstract version of what we've been doing this whole time, systems of equations. This is no different. This is just going to look different because it's algebra as opposed to unit conversions directly. But we are using the same principles we were doing all along. We have given equations. We have to solve a problem. We're doing something very similar. We're going to use the concept of what equal means to substitute in as appropriate. So for this example, I have 1x plus 1y plus 1z is equal to 6. I have the 1x plus 1y plus z divided by 3 is equal to 4. I have 1x minus 2y plus 2z is equal to 3. Okay. Instead of doing ratios this time, we're going to use a different property. We're going to say that, well, if 1x plus 1y plus 1z is equal to 6, then anywhere that I use 6, I could also use this. And if 1x plus 1y plus z over 3 is equal to 4, everywhere I have 4, I could substitute it with this. Very similar to what we've been doing. So if I use equations 2 and 1, I can subtract them. To make another true statement, I can say that 6 minus 4, so if I just subtract 4 from this, it's the same thing as taking this equation and subtracting this equation. Okay? So here it is. Here's what it looks like. 1x plus 1y plus z, that is equation 1. This is this side of equation 1. That was equal to 6, so the 6 is on this side. I'm subtracting the 4, which is also the same as 1x plus 1y plus z over 3. So I'm doing the same thing I was doing before. I'm just substituting equal statements. So if this is true, then I can distribute through, and I have 1x minus 1x plus 1y minus 1y plus 1z minus z over 3 is equal to 2. Those cancel out, and I end up with 3 over 3z, which is just 1. I broke this out into a fraction so that it makes it easier for us to subtract the fraction. So 3 over 3z minus 1 over 3z is equal to 2. Therefore, 2/3 of z is equal to 2. Therefore, z is equal to 2 times 3 over 2. Don't forget you have to invert the fraction, right? So if I divide both sides by 2/3, I'm dividing 2 by 2/3, that's going to invert and multiply. So I invert the 2/3 and multiply by the 2. That's where this comes from. That's equal to 3. Therefore, z is equal to 3. So this is not the only way to solve this problem. This is a way to solve this problem. These kind of problems are puzzles, and they may have many different solutions to get you to the final answer. You'll have one unique answer, but you may have many different approaches to get there. This is one such approach. So now that I have z is equal to 3, I can use another set of equations. You can't use the same equations twice. You have to use the other set, or else this will collapse on itself. So you need to use another equation. So we'll use this set of equation. We can see here that I have a negative 2y and a y. Something I can do is I can multiply this quantity by 2. So again, I'm multiplying 4 by 2, which is the same as multiplying this whole thing by 2. And I can think ahead and say, okay, if I do that, that will get this to a plus 2y, which would allow me to cancel out this negative 2y. And now that I know what z is, I can make this work to solve for x. So that's my strategy going into this, and that's what we're going to do now. So I multiply equation 2 by 2. So equation 2 is this one. So I have 1x plus 1y plus z over 3. So 1x plus 1y plus z over 3. That quantity multiplied by 2. I took the 4, it's on this side, multiplied it by 2. Because what we're doing here is we're multiplying 2 times 4 plus 3 in order to arrange this equation over here, because we're saying that everywhere that I have a 4, 4 is equal to this, and 3 is equal to this. So if I multiply this by 2 and multiply this by 2, I have not changed the equation. If I multiply this by 2, multiply this by 2, add it to this one, I have changed the equation, but I haven't changed the relationships between all the characters, all the variables. Okay, so this is, yes, a new equation. However, I have not changed the relationship between the variables. So this is legal. Okay, so I have 2 times 1x plus 1y plus z over 3. And I just brought the whole equation for 3 here. So 1x minus 2y plus 2z. That portion is equal to 3, and that's where this 3 comes from. Okay, so I'm saying that 2 times 4 plus 3, that quantity is equal to 2 times the quantity of 1x plus 1y plus z over 3, that plus 1x minus 2y plus 2z. This allows me to distribute and multiply to get 2x plus x. So I got the 2x from here and the 1x from here, brought it over here. 2y minus 2y plus, I have 2 divided by 3, so 2/3 of z from this, and I have 2z over here. So 2 times 4 is 8, plus 3 is 11. So that's where this comes from. So now that I have this, I want to go ahead and substitute in for z because I know that z is equal to 3. So now I have 3x plus 2/3 times 3 plus 2 times 3 is equal to 11. All we do is substitute in for z. Therefore, 3x plus 8 is equal to 11. Therefore, 3x is equal to 3, which means that x must equal to 1. So x equals to 1. So now that I have x and z, I can use any of my equations to solve for y. I chose the first equation. So substituting in x and z values now into equation 1, I get 1 times 1 plus 1 times y plus 1 times 3 is equal to 6. That's from equation 1. I said that 1x, which is 1, plus 1y, unknown, plus 1z, z is 3, is equal to 6. So that's what we have here. Therefore, y plus 4 is equal to 6. That can only be true if y is equal to 2. Okay? So, this is a little more complicated, potentially, and it's very abstract, but the same very basic principles we've been talking about, which is substituting in quantities of 1, quantities of equal values in order to solve a problem. Thank you for watching my video. Please like and subscribe. If you have any questions that I can help you out with, I'd be happy to try and answer your questions. Send me an email at morelearnmoreteach@gmail.com.